hear us?
Sure can.
All right. Do you want to do your little bit first then?
My little bit. Well, good evening. It's nice to see everyone. I was trying to scratch my head. I think the last time I presented was back in November 2024. And I believe most of you are, it looks like, yeah, familiar faces. So I'm assuming most of you were already at that talk. So I'm trying to think, I guess, what has changed in the platypus world since then. It's definitely becoming like a busy place, which is a good thing. A lot of great initiatives starting up. I think there's definitely now a shift to, I guess, really capitalize on the iconic flagship nature of platypuses, and to, I guess, promote water restoration, riparian restoration in many parts of the country, which has been really terrific. I guess a challenge there in many times is that there are a lot of initiatives that are like land care activities, for instance, that are restoring waterways. But we still really are not clear as to what's the time lag between starting to restore and when you actually start seeing positive responses of ecosystems. So that's something that's still kind of a gap for us. A lot of groups are keen to do restorations, but then they want to monitor platypuses and see responses, but those things can probably stagger a sequence of like maybe potentially even a decade or more. But really, like, going well, citizen science initiatives, a lot of the like major councils, we've got collaborations. There's with Brisbane City Council, there's a research group out west, Western Sydney University, that are doing a lot of work. So we're definitely progressing. The conservation status of the platypus in terms of, what we know of where we're headed in terms of platypuses, it's still not listed federally in that sense. Back at it's been 5 years since we put the first nomination that we were suggesting the platypus be listed as a threatened species, which got a pushback. I just did a submission a few months ago again I think it does warrant listing. The problem is with a species that is obviously so cryptic yet has such a wide distribution, the challenge is to acquire information about distribution and trends to meet those criteria is without a proper allocation of resources towards that is probably not very feasible. And so we're a bit in the same loop again, not enough information, so much uncertainty around really where platypuses are headed. We'll see what the Threatened Species Scientific Committee comes back at probably like this month, and they'll come up with a decision in November. So yeah, it'd be interesting to see what comes about that. But the platypus is, it's listed as a threatened species in the state of Victoria and endangered in South Australia. But the states no longer do state-by-state assessments. There's now a common standard assessment. So we tried to put a submission last year to Queensland, and they said, no, well, we're just doing now national assessments only. So we'll see how that unfolds, I guess. We've had a sequence of, a sequence of good years in terms of water availability. And so tying in, I guess, I'll tie into the reintroduction, but I guess one thing that came about, and I probably mentioned this in our talk 2 years ago, the motivation after the tinderbox drought and the bushfires that we had, it motivated, you probably all know about the rescue facility that has been established in Western Plains Zoo. And so as part of that, we are working and collaborating with Taronga to better understand really what are the criteria for us to intervene should platypuses and other species need intervention and particularly rescue. So in an environment that we've impacted to such an extent that platypuses are now unable to respond to drying conditions, move downstream in search of refugias, unable to, i.e. the case of the Royal National Park, unable to recolonize areas. We need to step in and facilitate those really critical processes. So this reintroduction, and also we've got research projects out west, like around Oberon and in some of the western flowing rivers further up north. We've been tracking platypuses. They're at an individual level and at a population level to try and understand really how they're responding to varying conditions. At the moment, we've had a sequence of good wet years. It seems like we're now probably as predicted. We go through the 10-year cycle, so it seems like now we're probably maybe moving into a drier phase. And so we've been, like I mentioned, closely monitoring individuals. We're tracking them, like same technology that Madison will showcase with these animals that we've translocated to the Royal. So we're tracking their movements. We're trying to understand all the metrics, the health, behavior, and so forth. And so it'd be very interesting for us to better understand how platypuses are responding to varying conditions over the coming years, and really how that gets translated to our vision of developing a national framework for ensuring long-term viability of the platypus as a species, and then the populations that are genetically and morphologically very different across the range. So there are a lot of considerations here as well, which came into consideration with these reintroduced animals as well that we did to the Royal National Park. So that's probably the biggest thrust or a project that we're focused on. The reintroduction has obviously been highlighted in the media and is like it's a high-profile species, high-profile park. The response has been terrific. I think we've definitely motivated a lot of initiatives, a lot of groups to consider the possibilities or to consider platypuses and the reintroduction of platypuses into a feasible vision. I don't know if you've heard in the news, there's now growing momentum of a team in South Australia to reintroduce platypuses back to the Adelaide region, the Torrens River. So we're supporting them in terms of the insights that we're gaining from this reintroduction in the Royal, and working very closely. We might see another high-profile reintroduction of platypuses in the coming years. So, and then there are other groups out there that are as equally motivated to see these kind of restoration and conservation actions unfolding. So, yeah, probably more in the news. That's me in terms of the intro. I think maybe I didn't like Madison. She's doing an honors project at UNSW now, so she's gonna give you all the background information in terms of how the reintroduction is progressing. I'll let her introduce herself and her work, and then we'd be open for questions after that.
Okay, I'll restart. So if you don't know me, my name is Madison, and I'm doing my honours project on the Royal National Park platypus reintroduction. The two key terms that you have to know basically to understand this project is that translocation is the deliberate movement of organisms from one location to another for conservation benefit. There are many types of translocation. The one that is most commonly used and the one used for this project is a reintroduction translocation, which is the deliberate movement of an organism from one location back into a site where they were historically present, but they've been removed in some form. So what is the project? The Royal National Park Platypus Reintroduction Project is a multi-year translocation effort that began in 2023. The aim was to establish a thriving platypus population in a location where the natural population is estimated to have become extinct 20 to 50 years ago. And how are we planning to do this? Well, 20 platypuses have been planned to and have currently been translocated from wild populations back into the hacking in staggered releases. This has been in 4 cohorts. We are currently in the 3rd cohort. Just one moment, guys. Perfect, okay. One moment, guys.
Just
so that you can't see this.
I was just about to ask that. Thank you very much.
That's okay. I'll see what I can do. There we go. There we go, guys. Sorry for the technical issues. Okay, so to give you a brief timeline of how the project has proceeded, 10 platypuses were soft released into the Royal National Park in 2023. If you don't know what a soft release is a type of release when you do a reintroduction translocation, which has 3 stages. So you capture a platypus from a wild source location, and then you bring it to a intermediary holding place. So in terms of this project, this has been the Taronga Zoo, where these 10 platypuses were kept for a maximum of 23 days, where they received medical care and were supplemented with shelter and food. Now, in 2025, 3 more platypuses were hard released into the Royal National Park. And as of this year, 4 more platypuses have been hard released into the Royal National Park. A hard release is another approach to a translocation release, and that is just when you take a wild platypus or any type of a wild animal and you take it from a wild population and then you immediately release it into the recipient location. So in terms of this project, that is sourcing platypuses from around Australia and immediately releasing them into the hacking. In 2027, 3 more platypuses will be released into the Royal National Park. So with my project, the summary of it is that essentially I'm going to be monitoring the post-release attachment of the 4 newly reintroduced platypuses, and I'm doing so using acoustic and radio tracking, otherwise known as acoustic and radio telemetry. What am I aiming to find out? I'm most interested in the post-release movement patterns and behaviors of these platypuses. So how far are they dispersing in a single day? How far are they moving from the initial release site? And we expect to see, based off of past the last 2 releases, that there will be initial high-frequency movement and dispersal, and then this will gradually decline as the platypuses transition from exploring their environment to eventually exploiting it. I'm then interested in comparing how these post-release behaviors differ between the platypuses that were soft released and the platypuses that were hard released. We expect to see that hard release platypuses will disperse less and establish their home ranges faster than the soft release platypuses, because they are less habituated to human handling. They were less reliant, or there were no provision of food or shelter. Their ability to forage and find shelter was not suppressed in any way. So we expect to see that they will be able to find burrow networks and home ranges much quicker. And finally, I'm interested to see whether their burrow and shelter that they choose have specific habitat preferences. We expect to see that burrow and shelter use and the habitat selection will consolidate over time as the platypuses transition from temporary opportunistic shelters to established burrow sites. Now, opportunistic shelters are considered to be debris shelters and rock crevices, while established burrows are excavated burrows. Why is this important? So globally, more translocations fail than succeed. And an analysis of unsuccessful reintroductions, 45.3% attribute that to the post-release behaviors that these animals exhibit. There is also limited study in a single species of how different release strategies influence successful establishment. There's no consensus on which strategy actually has a better outcome and which is more likely to lead to successful establishment. And arguably, most of the literature that has compared the two is focused on reptiles and not on mammals and birds. So, adding on to that, there is also limited study on burrow establishment and habitat selection following translocation. We don't know what their preference is for habitat when they are released into a new environment. So it's interesting to see what do they choose. We know that they preferentially select overhanging vegetation and will aim for natural structures like fallen logs and rock crevices. But we don't know how this changes in the scope of being introduced to a new environment and not knowing where any of these landforms actually are. In case you don't know what acoustic telemetry is, because I've been going on about it, it's a method of tracking the movement of the platypus using sound waves through water. So when we did capture them, we put a transmitter on the back of the platypus, and this signal can be detected and logged by a grid of receivers following the release. If you look to the map on the slide, each of the black triangles is a receiver that is placed in the Hacking River. So when the platypus passes by, it essentially logs that as a movement. And each of these transmitters that are attached have a unique identifier on them, so we know which specific platypus is moving past that receiver. So in total, 28 are released into the hacking. It stretches 14.8K of it and 3K of Kangaroo Creek as well in 500-meter intervals. And this is just to show you how this works. Basically, as it moves past it, it will ping it. It will log that it has been at that device. It goes for if you repasses it as well. And if you don't know what radio telemetry is, it's a method of tracking the movement of the organisms using radio waves on land. So we have both the water and land movement of the platypus. The tag is once again attached when we did capture them, and it's manually detected using a receiver and the directional antennae that you saw in the video. It acts essentially like a metal detecting device, where the closer that you are to an animal, the louder a signal is, and the stronger or the louder you hear the ping in the headphones of the device. So I'm going to go out of this presentation to show my results. So bear with me for a second. Okay, so each of these dots represents where a platypus has been found in the Royal National Park. Each of the different colors represents a different animal which has been tracked. As you can see, absinthe, which is one of our adult males that have been reintroduced, has spread far, far along the hacking, going from up to a lambie, all the way down to part of the forest path. So he's had a very good time exploring the Royal. If you compare that to the other reintroduced animals, you can see that they have also dispersed quite far along, and that they have had multiple burrow sites by now. It's also interesting where you compare it to the control animals, which are these three, and you can see that the spread between the burrows is much less. So they aren't exploring the park where the reintroduced animals are. And then to show you just another map as well. This represents, well, the shaded area portions represent the amount of detections at that single burrow site. So if we have a look at Dawn, one of our adult females that have been reintroduced, you can see that she very much likes this area or this burrow compared to the previous 3 sites that she was detected at. And then if we also have a look at Ducky, you can see that he has repeatedly been detected at several sites. This is also interesting when you compare it to the established platypus, where you can see that their detection is far more distributed and equal across the several burrow sites found. And finally, to go back to my presentation and to put that into perspective, I've identified 45 burrow and shelter sites, 19 of which are the established platypus and 30 are the reintroduced platypus. And I have noted that there have been 4 instances of shared burrow use between the reintroduced and the established animals, which is interesting for the fact of it's such a large site, meaning that they have somehow in such a long stretch of river been able to find a shelter that a previous platypus has used. And we're not quite sure how they're doing it so far, but it's interesting to actually note that they will search them out. And then finally, to also show you what these habitats look like, I've found 8 debris shelters, 13 rock crevices, and 29 excavated burrows. Debris shelters largely look like branches, logs, and other river debris that are washed into a concentrated space that they will use. A rock crevice obviously looks like a rock crevice, and the excavated burrows are largely found in sturdy banks where there's overhanging vegetation. And that's all I've got for now, guys, because the acoustic data set will not be available for another month or so. So unfortunately, I can't give you guys the initial results on the post-release movements or how it compares between the 2 release strategies. But I hope this tells you just a little bit about where the project is going. And yeah, thank you. And open to questions as well.
If you enjoyed this video, please like and subscribe. Consider becoming a volunteer yourself to help keep this iconic gem for future generations.